So we have a very unappreciated and underrated holiday this week. May 4th is Star Wars Day. May the 4th be with you. So I thought we should check in with some of our friends to see what they think about this lesson today.
I have a bad feeling about this. I've got a bad feeling about this.
I have a bad feeling about this.
Very bad feeling about this.
I got a bad feeling about this.
I have a bad feeling about this.
I got a bad feeling about this.
A really bad feeling about this.
I got a bad feeling about this.
I've got a bad feeling about it.
Quiet.
Whoa.
Ouch. Well, that wasn't very confidence inspiring, was it? Well, I still believe in you guys. I think you can do it.
The Emperor does not share your optimistic appraisal of the situation.
Ouch, that was rough again. Well, regardless of what everybody else's opinion has been, I still expect you guys to try on this homework.
Try not. Do. Or do not. There is no try.
Sorry, Yoda. When you're right, you're right. I stand corrected. So I'm expecting you guys to do this homework.
Timar the Math Wizard, have you seen my father?
I am your father.
No, that's not true. That's impossible.
Search your feelings. You know it to be true.
No! Timar the Math Wizard, I love you.
I know. Search your feelings. You know it to be true.
Oh, I'm sorry, Mr.
I'm gonna like react though.
Am I supposed to react after he says I know? Oh!
You could
Roll your eyes.
You could be like,
You can just.
Okay.
hello chemistry, this is the practice final with problems, part 1, day 1 of that, which is only doing the front face of this paper up to number 31, and then the next video will go from 32 to the end. So 1 to 5, just a quick summary. Significant digits exist to give you an idea how sure scientists are of a measurement. If someone just said something about 50,000 and wrote it this way, they aren't very sure. Okay? The rules on which digits were significant were anything other than zeros, which would be the 5. Zeros that had bars on them, which I don't have that here. Zeros that are in between other significant digits, which I don't have those. And zeros at the right end of decimal positions, which I don't have those. So this is the only significant digit in this problem. If I wrote the number this way, I'm saying there's 50,000 of something, but I'm not sure about this number itself. There might be 40,000. There might be 60,000. 50,000 is my best guess, but this digit is a little bit uncertain, and maybe it is 50,000, but I could be off by as much as 10,000 because I'm in the 10,000s place. If I went like this, now what I'm communicating is I'm sure about these, and this one's iffy, and this is in the hundreds place. So I still think there's 50,000, but I'm confident that I might only be off by 100. There might be 49,900, there might be 50,100. This is where I'm not sure. If I went like this, I'm very sure. Okay, this is now in the ones place, so I'm sure that I'm only off maybe by 1. I still think there's 50,000, no matter how I've used my punctuation, but now it's like somewhere between 49,999 and 50,001. I think there's 50,000, but only with a wiggle room of 1, because I'm in the ones place. They all look like 50,000, but they're at different ideas. So that's what this beginning is from. This is about where our year started, and that was a long time ago. So we're just looking to follow the rules. For 1 to 5, the first one has 3 significant digits. The 8, because it's not a 0. This first 0, because it's caught in between others. And then the 5, because it's not a 0. The second one has 6, because zeros on the right end of decimals are significant. The 5 is significant, and everything in between counts, so that had 6. The third answer has 2 because only the 4 and 5 count. When the zeros are not at the end of the decimal positions, but they start the decimal positions, those don't count. Those are just called placeholders. The .5400 has 5, the 5, the 4, and the zeros that are on the right end. Then the one with the bar, everything from the 4 to the barred 0, there's 5 of them there, would count as significant. That last 0 is just a placeholder. So that line, you have the answer key, so follow along. Some combination of my answer key, your paper, and what I'm saying can sort of guide you on this. To make there be 3 significant digits is going to involve some rounding or a little bit of creativity. So this, we start with the beginning. Zeros don't count when they're placeholders. This is a placeholder. 1, 2, 3. This is the third position. So maybe this is going to change, maybe it isn't. We're going to round. Looking to the right, 4 is not enough to change this. So I'm just going to ditch all those numbers, and now I have 3. For the 33, here's digit number 1, here's digit number 2. For me to have a third digit, I need to just go decimal point and add a 0, and now I have 3 digits. And this is significant because it's at the right end of the decimal positions. This, I'm going to just count digits. 1, 2, 3. This is the third position. The .5, usually 5s are enough to have us round up. But there was a rule in the chemistry book that if the 5s were followed by more stuff, they would always round us up. But if it was just a pure 5 and the number ended there, even numbers stayed evens. And if this were an odd number, it would round up to be an even. It was all about the evens. They didn't round up in the true math sense like you're used to. They made a sciencey rule where if every 5 rounded up, you'd end up overestimating over time. So they want half of those 5s up and half of those 5s down. Again, that rule only applies, this is our place, it's just a 5 and there's nothing else. If there's anything else after the 5, that rule goes out the window. But when it's a 5 at the end of a number making the rounding decision, it becomes all about the evens, that is 334. Here's digit 1, here's digit 2, here's digit 3. To make digit 3 significant, I just need a bar on that. After this decimal, these are just placeholders. This is digit 1. To make digit 2 and digit 3, I need some zeros just at the end of those numbers. 11 to 16, we have some rules that are different for adding and subtracting than for multiplying and dividing. Adding and subtracting's rules are to round first, and it depends on your place values. You want to use the least precise place. So if we go to add these, it helps maybe align them up. And you can see this number ended here in the hundredths place. This number went farther. So what we need to do is kind of draw an imaginary line here where we round, get rid of this stuff, so we're only working in the area where all the places existed. 4 is not enough to change the 5, so that can just get dropped. But if this were like an 8 or something, that would have rounded up to be a 6. And now add those. That'll be 99.47. For working to the right across the column, for multiplying, you don't round first. You do the math first. So you punch this in, and you'd see what appears on your screen. I didn't write that down on my paper, so I'll punch it, see what comes up on my screen. So 94.43 times 300 shows me 28329. What we do for this now is we look for the fewest amount of significant digits in the problem. This is a 4-digit number. This is only a 1 significant digit number because these are placeholders. So what we need for our answer is only 1 significant digit, which would be the first digit. So it's 2, we look to round based on this. 8 rounds us up to a 3, and then we just zero out the rest, and that's going to be 30,000. We only want a 1 significant digit answer because that had 1. Subtracting is like adding. You cut the problems all at the same place. This was cutting out in the tens place. So we need to round this number to cut it out in the tens place. 3 is too little to round up to 2, so that just gets dropped. But if this were a bigger number, like 5, 6, 7, 8, 9, we'd round it up with 3 there. Subtract that, and that turns you out to be the 73.9. Back to dividing. Dividing, we do the math first, we'll round later. So we're going to go 96.43 divides 1005.1. My screen says something like that is more than what I needed to write. But then we count. This has 1, 2, 3, 4 digits. This has 1, 2, 3, 4, 5 digits. We go with the fewer, which was the 4. And we round this answer then to the 4th position. After the decimal, 0 doesn't count because that's a placeholder. 1, 2, 3, 4, because that had 4. And 0 is not enough to change this, so we just drop all of that, and that's the answer written on our page. This one, you have to notice that I've rounded to the thousandth place. I zeroed this out to round to the thousandth place. So you have to round this to the thousandth place. The 8's enough to round this up to be a 2,000. Adding that up would make 100,000. But since we were working in the thousandth place as our point of emphasis, we need the thousandth place to show us a significant digit. So I need a bar on the thousandth place to show that that was the case. Then the last one from that group, just do the math first. 930 times 43.2. Calculator shows 40176. And then we count, we round last. This is a 2-digit answer. That 0 is a placeholder. This is a 3-digit number. So we go with the fewer, which is 2. And down here, I'll count. Digit 1, digit 2. This is where I need to round. 1's not enough to change that, so I zero it out. But since that's the digit I created, I need to communicate that that is a significant digit by putting a bar on it, and that's a 40,000 that has a bar. 17's rules, we need to plot the decimal down for scientific notation to make a number from 1 to 10. So the decimal should go there. One other number, then a decimal. So that's 8.55. Always times 10 to a power, and we just need to count how many places we just moved. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This, we want the decimal there, so we have a single digit, then a decimal. So 8.65 times 10. 3, 6, 9, 10 places we moved, but it's a negative 10 because we're moving the other direction. 19 to 28, we're doing some conversions. So there's 2 ways to approach those. One is to do dimensional analysis. A second is just to use some tricks that we've had before with zeros, metric prefixes, and just sliding the decimals. So I'll run you through both of those plans. It doesn't really matter which plan that you're after. So if we want to go dimensional analysis plan, start with the 6.6 megameters. To cancel megameters, put megameters on the bottom, regular meters on the top. Then you need to remember your metric prefixes. That it's 1 million regular meters make 1 megameter. Multiply those because they're on top, and you'll get the answer that I'm showing. I had to draw a bar on the first 0 to make it have 3 significant digits. If you want a non-dimensional analysis way to do that, you could try to remember we were doing it this way. When something had a bigger unit, it needed to have a smaller number. Mega meant million. So since this was a bigger unit, because it meant million, we needed to have it have a smaller number to begin with. When we changed it to meters, meters are littler, so we would need a bigger number to finish with. Mega has 6 zeros. If you just move the decimal 6 places, that's another way you could do that, but that's going to be confusing to some people. It's going to be quicker for other people. You make your call, what you're more comfortable with, sliding decimals, the right amount, or dimensional analysis. The 6.3 millimeter question, we would want to do, if we're doing dimensional analysis, millimeters to the bottom, meters to the top. Milli was a fraction for us, so it takes a lot of millimeters to make a meter. It takes 1,000 millimeters to make a meter. If you do this divided by this, you'll show the answer that I have on the page. I need that last 0 to have 3 significant digits. It starts with some placeholders, and then I need 630 to have a third digit there. We also want units on these, so remember to put your meters, your kilometers, or whatever the case may be. The hectometer question, we would first have to get from hectometers to meters. Hecto means that there's 100 of them. So 1 meter, 1 hectometer, is equivalent to 100 meters. So hectometers are out, meters are in. Then to get from meters to nanometers, I would need meters to go bottom to cancel. Nano was the smallest fraction of all the fractions. 1 meter made 10 to the 9th nanometers. Multiply these out, and you'd have it. If you're trying to think common sense kind of moving decimal schemes, hecto was big, it had 2 zeros for 100. Nano is small, has 9 zeros for the fraction involved. So 1 is 2 places on the large side, 1 is 9 places on the small side. Those are actually 11 places apart. 2 plus 9 is 11 places. If you move the decimal there 11 places, that'd be another way to make that answer. Celsius changing to Fahrenheit, you need this equation. Just take 1.8 times the 60, add the 32, you'd get 140 degrees Fahrenheit, and I put a bar on the 0 to have the third digit be significant. 140, that 0 needs the bar. To go Kelvin to Celsius, we need this equation. Celsius can be negative, Kelvin can't. Kelvin's 0 at the lowest. So if you want to go to Celsius, it's by subtracting 273. So just go 663 minus 273, we'd be 390. But to have 3 digits, as the directions instruct, 3 significant digits, I need a bar on the 0. 660,000 meters to get the kilometers. If we're doing dimensional analysis, go meters to the bottom, kilometers to the top. Kilo means 1,000, so 1 kilo makes 1,000 of the meters. Divide this by this. We'll always divide by numbers on the bottom. 660, again I need the bar on the 0 to make a third significant digit. 0.06 meters to make centimeters. Cancel meters by using the bottom, centimeters to the top. Centa is a fraction, 100th. So it takes 100 of the fractions to make 1 of the normals. Multiply them because they're on top. And again, I need to do some like 6.00 to make 3 significant digits. So the calculator just shows you 6, that's a 1-digit answer. 3-digit answer, we need a 0.00. 6.95 hectometers. We could work from hectometers to meters. Hecto means 100, so 1 of these makes 100 of the normals. And then I need to cancel meters to get to megameters. Mega meant million, so it takes 1,000,000 of these to make 1 of those. Multiply those because they're on top. Divide by that because it's on the bottom, and that'll show the answer there that we have. If you're trying to do common sense, move the decimal kind of system. Hecto is 2 zeros on the big side of town because it means 100. Mega is 6 zeros on the big side of town because that is meaning million. So if you're going from 2 to 6, that's a difference of 4 places. 6 minus 2 is 4. So we could just take this decimal and move it 4 places, and that would be another way that that could pan that out. Since we're making a bigger unit, million, mega, the number has to correspondingly get smaller. So that slid the decimal left 4 places. If you don't understand all this sliding and counting zeros, then don't do that. Do the dimensional analysis. Pick a system, either system. You like the dimensional analysis? Do it. You like sliding decimals? Do it. You just need to find one system that works. Fahrenheit to make Celsius. we need to obey that equation. So we're looking to do 63 minus 32, shows 31. Divide by 1.8, and your screen would fill, but you're going to want to round to the third position. It'll show 17 point, and you'll round to the 2, because that's the third digit. And then the last one of that group, we're going to obey the equation that Kelvin is equal to Celsius plus 273. 273 should be in your memory from absolute zero and memorizing that. Kelvin has to be positive, so take the Celsius, add 273 to it, and that should show up 907. And then we'll cut there. So for the last three problems, 29, 30, 31, we're looking to do dimensional analysis. So whatever number I give you goes in the first position, so that's 5 miles. We want to get rid of miles, which is on the top, so we put miles on the bottom. And look around for tips in the problem. It says 5,280 feet, 8 miles. So let's use the 5,280 feet with 1 mile and make a conversion. And then see if that's what we wanted. Did we want feet? So we look at the question, and we are after inches. So we need another change. Feet on the top makes us put feet on the bottom. And we can turn feet into inches because 12 inches make 1 foot. Ignore the ones for doing the math on the calculator and just multiply all the numbers on the top. 30, similar kind of thing. We have years, so we'll get years on the bottom. We can turn years into days because there's a tip in the question itself to say there's 365 days in a year. And then we see if that's what you want. Do you want days? You don't want days. So we need to turn days into something else. So put a match to cancel on the bottom. Probably best to turn days into hours because there's 24 hours in a day. We still don't want hours, so to re-cancel hours, get a partner on the bottom to get a cancel. There is 60 minutes in 1 hour, and we're getting closer because we're trying to get to seconds. So we need to get rid of minutes by creating a cancel situation to get to seconds, 60 seconds in 1 minute. Again, we can ignore all those ones. Multiply all the numbers on the top. Last one of this group, we have 50 cubits trying to get to yards. So there's a tip in the question to help you cancel cubits and get you to inches because it says there's 18 inches in a cubit. But we don't want to get to inches, we want to get to yards. So we'll have to cancel inches to get to yards. 36 inches make a yard. For the first time in this cluster, we have a number on the bottom, so we'll have to hit the divide by button. 50 times 18, and then divide by the 36 on the bottom. And that's it for today. If you have more questions, get me on Zoom sometime.